We'll start. So it's time to start. So thank you for attending to this roundtable. The talk of the title of this roundtable is "Optimize Your API with Event-Driven Microservice Architecture." So we will have 25 minutes with Jeffrey from Confluent. And again, we received some questions from you before the roundtable. So Jeffrey was great. He included them in the roundtable. If you have any question, you can ask them directly. All right. So let's start this roundtable about event-driven architecture, microservices, and optimization. Right. So hello, Jeffrey. How are you?
Hi, good morning. It's great to be able to speak at the API Days event. Um, Thanks a lot. It's great to
Yeah.
meet you
No,
all.
we're really good. We're really glad to have you. So again, let's start by asking you this first question about can you tell us why is event-driven architecture necessary these days, and what are the challenges in such API architecture?
Yeah, I think there's a lot of customer that we visit. We have seen a very common scenario where they try to put everything as synchronous API calls, right? As we all know, API calls, like something you send a request, you wait until the process finished, get the response, and continue, might be calling another API call, and so on, right? So, and when we developed these kind of API calls, if the process that we are calling are down or they're slow or they're getting changes of a new version, then we are all depending on it, right? And as we see our customers continue to expand their API deployment, a lot of them will start doing layering, like what you see in the diagram, right? Different layers so that it is cleanly laid out, but then it also means that you have more and more dependency, right? What if, something goes down, then it might impact different kinds of services up the stream, right? And if something is running slow, it is impacted, very hard to trace performance issues in runtime, as you know. And if you're changing versions, right, you got to do very elaborate change management, impact analysis, and how do you apply the governance and security across the board? How do you do logging across the board? It all becomes an issue because for the scaling with more and more, how do we deploy more and more API services, right? If you have bigger and bigger dependency between all these API calls, right? So that becomes a, a issue that a lot of our clients are facing these days, right? Now, on top of that, right? Um, when we look across the industry, like for example, one of our FSI customers, pretty representative. They have it's a regional FSI, right? They cover more than 10 geo markets in APAC. A lot of them are through acquisitions, and they want to enhance customer experience. They want to do a lot of big machine learning and AI as their strategic move, and they are moving to cloud, right? So all of a sudden, they need to look at the API architecture from a completely different perspective, right? How do we deliver things in real time, right? Between the services of the API calls you see in the last diagram, if the data, a lot of the data are still replicated between them by batches, right? How do they get real time, right? The data need to get real time as well, right? How do they get decoupled, right? How do they get domain based uh, from centralized, right? Because they have lots of geo market across APAC. They have different policy, different business goals, and driven by different organization because traditionally a lot of them are from acquisition as well, right? Even within one geo market, there are many different departments that have that they really need to decentralize the management of the data and services, right? Going to the domain-driven application and also for data domain. And they are moving to cloud, right? So how do they still migrating different services, some on premises, some on cloud, and they can still communicate seamlessly with data exchange between them in real time, right? Um, And now if they move to big data, right? Initially they were dealing with transactions, more on transaction in terms of analytics and processes. Now they move to AI, they need to deal with big data. The the volume is changed, just it's just magnitude of difference of data volume that they need to handle, right? So all these force them to rethink about the architecture, and they come to us to look at the event-driven microservices architecture and the data mesh architecture, which and that's where they're coming from.
Yes, and Jeffrey, just a quick feedback here. I was with a company like chief architect who was telling me they had microservices with an uptime of 99.99%, like 29 after the commas. But he were using synchronous APIs, and so one of the business call was calling 30 different services that were all waiting for each other. So 30 services, all available 99.99% of the time,
Yeah,
at the end, because they have to wait one of each other, that was 99.7%, which means 2 hour and a half a month down. So it was definitely, he said that synchronous APIs or polling APIs, as we call them, were not the case, and this is why he was trying to go to event-driven architecture, right?
yeah, that's very right. Some of the company that we are seeing, they try to build some super app, right? Because they want to streamline all the customer experiences across all the services they offer with one application, right? Mobile app, right? So that will also, that kind of also magnify the issue that was just talked about, right? Because you have all these kind of services touching almost all the important backends in your organization, right?
No, yep, and definitely. And then it goes about a second question, like, so how, let's say, how event-driven architecture augment the synchronous API model, like what's the advantages, what's the benefits of, and what's actually the main concepts behind that.
Yeah, so the main concept is like, you do asynchronous call and between the services. For example, Kafka is now pretty much a de facto event-driven platform across industry, right? If you look at that, right, uh, you have different services in this diagram. Instead of having the web and the hierarchy, the layering, each individual services will produce or consume from the platform asynchronously, which means that when they produce a message, is completely decoupled from the consumer of the service. So in this way, the deployment is decoupled, the performance is decoupled. If one services is down, the data is still produced and logged uh, uh, as immutable logs in the platform. So when the services come back up, it will read it again, right? So essentially, if you have like one service calling 30 APIs, right, that service just need to produce the event onto the Confluent or Kafka platform, and then other services will pick up, right? But they are all decoupled, right? So this is the way that kind of we solve the issue, and just think about this, right? It become a lot more scalable, right? We have a lot of customers. Instead of taking might be a few hundred or 1,000 transactions per second from asynchronous API, when they move to asynchronous, all of a sudden they can take 10 times or 20 times more more calls per second, become a lot more scalable in real time. And also think about uh, the uh, how it works, right? Essentially, you you're not just publishing or producing and simple consuming the data from a pipeline. uh, what if you can have all kinds of services now producing to the platform, and you can do real-time processing right away to trigger your backend microservices, might be for your backend operations, or might be in the important workflow, or might be enriching the customer experience right away. right? This is the power that we are talking about with the decoupled architecture, right? You know, basically what it means is that we you can connect Kafka with the pre-built connectors uh, to all kinds of services, right? All kinds of databases, queuing, and all kinds of application, even for SaaS application, even for your SaaS data services, you can connect to it, right? All these data are streamed in real time into the Kafka platform as independent events, right? And you can also sync it to your target, right? A lot of companies are moving to on-premise to cloud, so you can sync it to your cloud in real time right away. And in the middle, within the circle, uh, you're not just passing data from the left to the right, but you can do processing. For example, if you have a real-time order coming in, you can enrich it right away with the customer table, whether he is a gold, silver customer, whether you have to do KYC, whether you have to do fraud analytics, or whether you're looking at the click stream and combine with what they're doing and make a decision. You can trigger microservices, right? After processing them, join them together, filtering, right? And you can also turn it into a stateful table, like a materialized table if you want, right? Or non-materialized, right? And you can do query upon it as well. And you can do it through API by whether it's you're producing and consuming to Kafka, whether you're querying from the table after the join filtering and all that, or whether you are querying, whether you are accessing the microservices that take advantage of the data. Now, in this way, you still have the REST API that enable you to do what you want, but then you decouple the architecture. So this is what we're looking at. And in the FSI customer that we talk about, right? They are also turning it into a domain-based kind of architecture, right? Instead of a centralized team owning the centralized application, they break it down in terms of application and data. This is very important for them because, as FSI, data sovereignty is very important from different markets in APAC, right? You can't just pass all the data freely around. They got to manage their own data. They got to manage their own application, and they got to do the proper security, right? Under their control, under their management before they share it with other people, right? Maybe they want to share all 10 plus market to do more machine learning or AI, right? But you got to clean up the data. The only way you can do that is the decentralized kind of data architecture as well to augment the API architecture. And we actually have a more detailed presentation at 12:30 today talking about how to do data mesh and data API with Confluent. Thank you,
Yeah,
Manish.
in your examples, you've mentioned some banking services, or here I see like some logistics, inventory,
Mm,
shipments, or whatever
yeah.
orders. Where do you see application in what type of industry do you see application?
Yeah, actually, we have been seeing this as a trend across industry. We have lots of banks, insurance company. We see a lot of retail companies, telcos, and manufacturing companies with IoT, etc. This is a trend. The reason of people going to data mesh is that traditionally the data are managed by a central team which quickly become the bottleneck, right? As you can see, if you want to, everybody is producing data, everybody is producing API, right? And then that's why people really trying to break it down into different domain and with event-driven architecture.
So
Yeah,
really cross industry, as long as you said moving to the cloud, data and AI, the need of real time. So all the trends you were saying earlier applies, right? And I think it applies to many
exactly,
industry. Yeah.
exactly.
So every new technology or new architecture principle comes with a lot of advantages, but also comes with things that are maybe not relevant. So then the question is like, when when not applying event-driven architecture, when do you still need, or when it's still better to use synchronous APIs?
Yeah, definitely. Synchronous architecture and asynchronous always go hand to hand, hand in hand together, right? There are things like event-driven architecture is not as good. Like for example, if you want some super fast transaction, right? We have FSI customer that talk about nanosecond, right? Kind of architecture. Right? This is not what asynchronous can do, right? It's not built for that, right? So like Kafka can handle like millisecond level, like single-digit millisecond kind of produce and consume, right? But not the millisecond or nanosecond level, right? Secondly, if you're talking about the interactive UI with the consumer, where you still expect a request response kind of experience, right? You still want like a synchronous API, right? Like just a clarification, we're not talking about the kind of interactive Uber kind of like a experience where you see what the car where the car is, like what is the price is, and how many minutes, right, to get to you, in real time. All these are more like event driven, right? You get the geolocation of the car and where you are and the real time pricing. All these can be real time event driven as well with Kafka, but not the but if you're talking about I make a bank payment, I want to see the result right away, whether that go through, instead of somebody telling you that your transaction is committed, and then you get the result might be 5 seconds later or half a minute later, right? If you want that kind of interactive UI experience, then you still want synchronous API, right? So there's still many cases that you want to have synchronous and event driven together.
Yeah, that makes total sense. So also a question that we have a lot is about like how to when we expose APIs internally, then we may at some point expose them externally, right?
Yeah.
So event-driven architecture, how and external APIs, like how does that work? Is it working? Is it secure? Like how what advice you would give to people for that?
Yeah, definitely. Yeah, it's a really good question. Like we in the previous slide, I talk about, in within the process, right? How do you expose it for API for internal purposes, right? Of course, there are many ways, just like in the diagram. Like externally, you can still expose the same API that I talk about to external. Might be through an API gateway because they're already exposed as REST API, right? Might be you also want to put a proxy and all that to make sure that security is done, right? So what I talk about in the last slide also apply to external, right? When I say external, just like the FSI regional FSI that talk about, uh, they might it might be because they are deployed on different cloud network, right? With Confluent, we provide SaaS cloud service, fully managed SaaS services on the major cloud vendors, AWS, Azure, and GCP, and as well as on premises. So you can imagine that all these interfaces, some company might consider it as treated like need a very secure way to expose the data, right? So that's where you will leverage the API gateway and proxy again. And also a lot of the company are looking for integrating with ecosystems, right? Like a lot of the banks are thinking about integrating with the e-commerce partner. And if you talk about if you are if you have client or if you are like a digital company, like definitely I'm sure that you're looking at integrating with all kinds of partners through API on the internet as well. So this is, where you can still leverage the API gateway and proxy, etc., to make sure that things are done in a secure way. Thank you. And also we have another workshop immediately after this roundtable on stream processing with the REST API and the KSQL DB, which is our SQL-like language, which can do the real-time processing, as well as the Kafka Stream, which is our Java library that can, but essentially they are Kafka clients, right, that can do the processing in real time.
So you mentioned DB, right? And it's true that we also have this question, like, because Kafka has its own persistence. So do you still use databases in this event-based architecture with Kafka? Like, how does that work?
Yeah, yeah. Like as a lot of the attendants will know, right? Kafka has its own persistent, which means all the event that you have produced uh, will be persisted as immutable log, right? The advantages is that if you have, let's say, if you have, you can replay anytime, right? Let's say that you want to do analytics, you want to do additional machine learning, right? You can just you don't have to change any producer or consumer, like everything is decoupled, and you can uh, have the machine learning replay the data from Kafka so that it can do the learning that you expect to do, right? Or if you have new use cases, right, that new uh, the microservices does not need to impact the existing microservices. You don't have to add the logic in the existing microservices. You can just build new microservices to replay from Kafka, right? And that makes the entire thing decoupled, right? However, you still want to leverage databases in many cases. Like in Kafka, we have connector that you can sync to your SQL or non-SQL or real-time analytics or other kinds of databases, right? You still want to do that, right? Because like Kafka is immutable log, right? Uh, it does not have the indexing like the traditional databases, right? Or it doesn't have the other kind of relationship in your graph databases or other NoSQL databases, which you want to leverage. So if you want to do that kind of analysis, if you need to access the data in that way, right, in from a traditional SQL or NoSQL database, you still want to sync your Kafka data in real time into those databases to provide the kind of uh, you know feature and capability that your application need. Right. So you got the best of both worlds, right? You can still leverage the different kind of databases, right, that you see the most fit. At the same time, you get the real-time data, cloud, reach to cloud, and all the trending that I talk about in the last slide.
Yeah, so we have a
Yeah,
few
thank
minutes
you.
and we have four questions from the RSVP list and from the attendees of the roundtable. Like the first one is how should API deal with eventual consistency?
Mm. Yeah, it's a very good question, right? Um, like because it is event driven, right? You don't have the strong consistency or immediate consistency, right? You have to deal with eventual consistency, right? Like now, I would recommend you to look at these some of the books, or this is one of the website where you will find a more elaborate event microservices pattern that leverage event-driven architecture, right? Which you can build on Kafka and Confluent, right? So, but specifically about uh, eventual consistency, one of the pattern is called the saga pattern, right? So essentially, it's very simple, right? You still have a like request response, right? But in case you find that there is a unsuccessful path, right? You will compensate for that, right? Basically, if you find out that if you go to service A, and then when you write to service B and find out that something is wrong, service B will send back the error event, and then service A will need to know how to compensate for it, right? You can do it through, once you compensate for it, right, it kind of trigger all kinds of services or get back to the customer that it is compensated, right? So
Yeah.
conceptually very simple, and you can follow the patterns in the books or the website that I talk about to implement it in Kafka, right?
Yeah,
And
and we have 30.
essentially,
Oh, sorry.
yeah, essentially it is, if you look at it, right, eventual consistency, what you miss in the asset, right, is the isolation, right? And that you need to compensate for these kind of issues that you see from the lack of isolation, right? Thank you.
And in 20 seconds, we have a question about how to avoid API loops that might cause an infinite ripple effect in an event-driven architecture microservices.
Yeah, yeah, I think it's a very good question too. Like you can also look at the pattern that I talked about in the previous website, right? Or books, right? To resolve the issue, right? Basically, it is pretty simple, right? Like you can actually look at the event and you see whether it is duplicated event, right? And you can uh, when you have that, then you know that it is idempotent, right? You don't execute it again. Yeah, thank you.
Yeah, thank you very much. I think we try to answer all the question. And again, for the one interested, so of course it's recorded. If you want to share with colleagues or if you want to watch it again, Confluent has a virtual booth at the event, so you can go there and to continue the discussion. Also, and now there will be another roundtable and workshop happening in another room about stream processing with KSQL DB and REST API queries by Sanvi Sabapati, Senior Solution Engineer at Confluent. Thank you very much for being with us, Jeffrey. And looking forward continuing the discussion at next APIs conferences.
Yeah, my pleasure. Have a good day.